Hi, and welcome to another episode of Astronomy Daily. I'm Steve, your host. It's the 14th of October, 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, another exciting episode, very colourful as well. I'm excited because we witnessed history yesterday, didn't we, Hallie?
Yes, the SpaceX Heavy booster landing.
That's right, Hallie. It was the most magnificent piece of space engineering and technological genius I think I've ever seen, ever.
It was astounding, all right.
And, of course, we'll get to that later. Other stories today include, our old favourite, europa-clipper.
Space lasers.
Really?
Really?
No, Hallie, I mean, really? Space lasers? Really?
Yes, human. NASA tested one.
Oh, okay.
It's a beauty, as you Australians like to say.
Ooh, Hallie, trying out the Aussie accent. Yeah, nah. Better download the software for that one.
No one can do it.
Yeah, that's a dead cert, Hallie. No one can do it.
You think?
No, we know it.
Beauty, mate.
Oh, crikey, Hallie, you're putting my teeth on edge.
And you don't have to download anything?
No, I just kind of grew into it. Little Vegemite, maybe a Chico roll. She'll be sweet.
Good grief. And we're off track already.
Oh, for sure, Hallie. What else we got?
I've got a bit about Comet Tsuchinshan-ATLAS.
Oh, nice. But don't ask me to say that one quickly or slowly. And tell me, have you been checking out the auroras around the planet this week?
Haven't they been beautiful?
I know, they're just gorgeous. And I'd like to invite our listeners to post their pics on our X page, and I'll give you the address for that. It's at AstroDailyPod. So post your pics there.
If you have some photos of the auroras from your neck of the woods, we'd love to see them.
Oh, totally. Yeah, let's see them, folks. And to kick things off, I did get some great images from my good pal John Carl in Tasmania. He went out to view the colours in the sky with his brilliant daughters, and they had a terrific time out there. And in true Tasmanian style, it was cold, but the aurora did not disappoint, and Carl was kind enough to allow me to post the photos, which I will do very shortly. And you'll be able to see those on at AstroDailyPod. That's the X page.
So it must be time for the news.
It sure is, Hallie. Thanks for that. And why don't you take it away?
Open the pod bay doors, pal.
Oh, boy.
Earth-based observers scanning the night sky in autumn 2024 may witness a celestial event that occurs only once every 80,000 years. Comet C/2023 A3 Tsuchinshan-ATLAS originated from the distant fringes of our solar system and reached its closest approach to the Sun on September 27. It is and is expected to pass within about 70 million kilometers or 44 million miles of Earth on October 12. Initially visible mainly in the southern hemisphere and the tropics until October 8, the comet offered increased viewing opportunities for those in the northern hemisphere in the following days. Crew aboard the International Space Station have also been observing Tsuchinshan-ATLAS on its journey through the inner solar system. An astronaut captured this photo of the comet on September 19, 2024. At that time, the mass of dust, ice, and rock was approaching the closest point to the Sun on its highly elliptical orbit. The photo also offers a cross-section view of Earth's bright horizon, or limb, and the planet's colorful atmospheric layers. When a comet approaches the Sun, it gets warmer. Heat causes its ice to sublimate into gas, and these gases and dust become a glowing coma and tail that can extend millions of kilometers. The Sun influences the two types of tails, the dust tail and the ion tail trailing from the comet, in different ways, often sending them in different directions. The heat and pressure of sunlight push particles in the dust tail away from the Sun, though the tail may bend slightly in the direction the comet came from. Likewise, the solar wind strips ions off of the comet's surface to create the ion tail, which may extend at a different angle. Some comets do not survive close encounters with the Sun. If they get too close, radiation and gravitational forces may disintegrate them completely. Tsuchinshan-ATLAS did not suffer this fate, but another comet astronomers were watching, C/2024 S01-ATLAS, may have. Recent data suggest that this comet, which was expected to be visible from Earth later next year, may have recently broken into fragments. Given their extremely long orbits, both of these ancient celestial travelers likely originated in the Oort cloud, which is a large spherical shell of icy debris at the outer reaches of our solar system. C/2023 A3 Tsuchinshan-ATLAS was discovered in 2023, identified by observers at China's Tsuchinshan, or Purple Mountain, Observatory and an ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, Telescope, in South Africa. It was officially named in honor of both observatories. NASA's Deep Space Optical Communications Technology demonstration set a new record for laser communications this summer by transmitting a laser signal from Earth to the Psyche spacecraft, approximately 290 million miles, 460 million kilometers, away. That's the same distance between our planet and Mars when the two planets are farthest apart. Shortly after achieving this milestone on July 29, the technology demonstration successfully completed the initial phase of its operations, which began with the launch aboard Psyche on October 13, 2023. Soon after reaching that milestone on July 29, the technology demonstration concluded the first phase of its operations since launching aboard Psyche on October 13, 2023. The milestone is significant. Laser communication requires a very high level of precision, and before we launched with Psyche, we didn't know how much performance degradation we would see at our farthest distances, said Meera Srinivasan, the project's operations lead at NASA's Jet Propulsion Laboratory in Southern California. Now the techniques we use to track and point have been verified, confirming that optical communications can be a robust and transformative way to explore the solar system. Managed by JPL, the Deep Space Optical Communications experiment consists of a flight laser transceiver and 2 ground stations. Caltech's historic 200-inch or 5-meter aperture Hale telescope at Caltech's Palomar Observatory in San Diego County, California, acts as the downlink station to which the laser transceiver sends its data from deep space. The Optical Communications Telescope Laboratory at JPL's Table Mountain facility near Wrightwood, California, acts as the uplink station, capable of transmitting 7 kilowatts of laser power to send data to the transceiver. By transporting data at rates up to 100 times higher than radio frequencies, lasers can enable the transmission of complex scientific information as well as high-definition imagery and video, which are needed to support humanity's next giant leap when astronauts travel to Mars and beyond. As for the spacecraft, Psyche remains healthy and stable, using ion propulsion to accelerate toward a metal-rich asteroid in the main asteroid belt between Mars and Jupiter. The technology demonstrations data is sent to and from Psyche as bits encoded in near-infrared light, which has a higher frequency than radio waves. That higher frequency enables more data to be packed into a transmission, allowing far higher rates of data transfer. Even when Psyche was about 33 million miles or 53 million kilometers away, comparable to Mars' closest approach to Earth, the technology demonstration could transmit data at the system's maximum rate of 267 megabits per second. That bit rate is similar to broadband internet download speeds. As the spacecraft travels farther away, the rate at which it can send and receive data is reduced, as expected. On June 24, when Psyche was about 240 million miles or 390 million kilometers from Earth, more than 2.5 times the distance between our planet and the Sun, the project achieved a sustained downlink data rate of 6.25 megabits per second, with a maximum rate of 8.3 megabits per second. While this rate is significantly lower than the experiment's maximum, it is far higher than a radio frequency communications system using comparable power can achieve over that distance. The technology demonstration beamed the first ultra-high-definition video from space, featuring a cat named Taters, from the Psyche spacecraft to Earth on December 11, 2023, from 19 million miles away. Europa-clipper will peer beneath the Jovian moon, Europa's icy crust where an ocean is thought to be sloshing fairly close to the surface. It won't search for life, but rather determine weather conditions there could support it. It's a chance for us to explore not a world that might have been habitable billions of years ago, but a world that might be habitable today, right now, said program scientist Kurt Niebuhr. Its massive solar panels make Clipper the biggest craft built by NASA to investigate another planet. It will take 5.5 years to reach Jupiter and will sneak within 16 miles or 25 kilometers of Europa's surface, considerably closer than any other spacecraft. Costing about $5.2 billion, liftoff is targeted for this month aboard SpaceX's Falcon Heavy rocket from NASA's Kennedy Space Center. One of Jupiter's 95 known moons, Europa, is almost the size of our own moon. It's encased in an ice sheet estimated to be 10 miles to 15 miles or more or 15 kilometers to 24 kilometers thick. Scientists believe this frozen crust hides an ocean that could be 80 miles or 120 kilometers or more deep. What type of life might Europa harbor? Besides water, organic compounds are needed for life as we know it, plus an energy source. In Europa's case, that could be thermal vents on the ocean floor. Deputy project scientist Bonnie Baratti imagines any life would be primitive like the bacterial life that originated in Earth's deep ocean vents. "We will not know from this mission because we can't see that deep," she said. Unlike missions to Mars where habitability is one of many questions, Clipper's sole job is to establish whether the moon could support life in its ocean or possibly in any pockets of water in the ice. When its solar wings and antennas are unfurled, Clipper is about the size of a basketball court, more than 100 feet or 30 meters end to end, and weighs nearly 13,000 pounds or 6,000 kilograms. The supersized solar panels are needed because of Jupiter's distance from the Sun. The main body, about the size of a camper, is packed with 9 science instruments, including radar that will penetrate the ice, cameras for mapping virtually the entire moon and tools to tease out the contents of Europa's surface and tenuous atmosphere. The roundabout trip to Jupiter will span 1.8 billion miles, 3 billion kilometers. For extra oomph, the spacecraft will swing past Mars early next year and then Earth in late 2026 and arrives at Jupiter in 2030. Then it begins science work the next year. While orbiting Jupiter, it will cross paths with Europa 49 times. The mission ends in 2034 with a planned crash into Ganymede, Jupiter's, and the solar system's biggest moon. There's more radiation around Jupiter than anywhere else in our solar system, besides the Sun. Europa passes through Jupiter's bands of radiation as it orbits the gas giant, making it especially menacing for spacecraft. That's why Clipper's electronics are inside a vault with dense aluminium and zinc walls. All this radiation would nix any life on Europa's surface. But it could break down water molecules and, perhaps, release oxygen all the way down into the ocean that could possibly fuel sea life. Earlier this year, NASA was in a panic that the spacecraft's many transistors might not withstand the intense radiation. But after months of analysis, engineers concluded the mission could proceed. Like many robotic explorers before it, Clipper bears messages from Earth. Attached to the electronics vault is a triangular metal plate. On one side is a design labeled "Water Words" with representations of the word for water in 104 languages. On the opposite side, a poem about the moon by U.S. Poet Laureate Ada Limon and a silicon chip containing the names of 2.6 million people who signed up to vicariously ride along. And that's all from me today. Back to you, my favorite human.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at AstroDailyPod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
In one of the most dramatic high-risk space flights to date, SpaceX launched a gargantuan Super Heavy Starship rocket on an unpiloted test flight on Sunday, and then used giant Mechazilla robot arms on the pad gantry to pluck the returning first stage out of the sky in an unprecedented feat of engineering. The Starship upper stage, meanwhile, looped around the planet and re-entered the atmosphere over the Indian Ocean just as planned, enduring temperatures of nearly 3,000 degrees as it descended to a controlled, on-target splashdown. The spacecraft appeared to come through the hellish heat of re-entry in relatively good condition, protected and by improved heat shielding tiles and beefed up steering fins that worked as needed while engulfed in a fireball of atmospheric plasma. But the jaw-dropping first stage capture back at the launch pad using pincer-like arms, more commonly known as chopsticks, was the clear highlight of the giant rocket's fifth test flight, snagging the descending 23-story tall Super Heavy booster with the Mechazilla arms represented an unprecedented milestone in SpaceX's drive to develop fully reusable, quickly relaunchable rockets, a technological tour de force that stands alone in the history of earlier space programs relying on expendable throwaway rockets. Big step towards making life multi-planetary was made today, SpaceX founder Elon Musk said on his social media platform X. The 397-foot-tall rocket blasted off from SpaceX's Boca Chica, Texas flight facility on the Texas Gulf Coast at 8:25 a.m. EDT, putting on a spectacular sunrise show as the booster's 33 methane-burning Raptor engines ignited with a ground-shaking roar and a torrent of flaming exhaust. With 3 minutes and 40 seconds after liftoff, the Super Heavy booster fell away, flipped around and restarted 13 Raptors to reverse course and head back toward the Texas coast as the Starship upper stage continued to climb to space on the power of its 6 Raptor engines. The booster's flight computer was programmed to direct the stage to a splashdown in the Gulf of Mexico if any problems developed on the rocket or the launch pad capture mechanism. But no such problems were detected. The flight director sent a required go command and the Super Heavy continued toward its launch pad, descending at an angle and then straightening up as it approached the gantry. As it slowly dropped beside the tower, the 2 mechanical arms smoothly moved in to grab the rocket as its engines shut down. The remarkable capture, a key element in Musk's drive to achieve rapid reusability, came as the Starship upper stage was still heading into space and splashed down in the Indian Ocean, simulating a touchdown on shore or eventually on the Moon or Mars. During the rocket's 4th test flight in June, the extreme temperatures caused significant damage to the Starship's protective tiles and steering fins. Multiple upgrades and improvements were put in place for Sunday's flight to eliminate or minimise any such re-entry damage. As the Starship re-entered the atmosphere, cameras on the rocket showed the reddish glow of heat building up on the belly of the spacecraft, intensifying as the descent continued. Engulfed in a fireball, the ship's fins stayed intact and the vehicle came through the peak heating in good condition. Moments later, the camera captured an on-target splashdown, followed by what appeared to be an explosion. Given the rocket was not intended to land in water, whatever happened after splashdown was incidental in what can only be called a remarkably successful test flight. The 2-stage Super Heavy Starship, known collectively as the Starship, is the largest, most powerful rocket in the world, with twice the liftoff thrust of NASA's legendary Saturn V and nearly twice the power of the agency's new Space Launch System moon rocket. The 30-foot wide Super Heavy first stage, loaded with 6.8 million pounds of liquid oxygen and methane propellants, stands 230 feet tall and is powered by 33 SpaceX-designed Raptor engines, generating up to 16 million pounds of thrust. The Starship upper stage measures 160 feet long and carries 2.6 million pounds of propellant to power another 6 Raptors. Both stages are designed to be fully reusable, with the Super Heavy flying itself back to the launch pad while the Starship travels to and from Earth orbit, the Moon, or eventually Mars. The Starship is designed to touch down vertically on its own rocket power at landing sites on Earth and beyond. But the primary goal on Sunday's flight was to demonstrate the ability to capture returning Super Heavy boosters on the launch pad, where they can be quickly refurbished, refueled and relaunched. SpaceX perfected first-stage landings with its workhorse Falcon 9 rockets, successfully recovering 352 such boosters to date, with powered touchdowns on landing pads or offshore drone ships. The smaller Falcon 9 first stages land on their own, deploying 4 legs a few seconds before touchdown. Snatching the 397-foot-tall Super Heavy out of the sky with mechanical arms as the rocket descends and hovers right beside its launch gantry seemed like an outlandish idea when it was first proposed during the booster's initial development. But SpaceX engineers spent years preparing and months testing for the booster's catch attempt, with technicians pouring tens of thousands of hours into building the infrastructure to maximise the chances for success. With each flight building on the learnings from the last, testing improvements in hardware and operations across every facet of Starship, we're on the verge of demonstrating techniques fundamental to the Starship's fully and rapidly reusable design, the company continued. SpaceX is under contract to NASA to supply a modified Starship to carry astronauts to landings near the Moon's south pole in the agency's Artemis-programme. To get Starship lander to the Moon, SpaceX must first get it into low Earth orbit, then launch multiple super heavy Starship tankers to refuel the Moon-bound Starship for the trip to lunar orbit. The astronauts will launch atop NASA's Space Launch System rocket and fly to the Moon aboard a Lockheed Martin-built Orion capsule. The crew will transfer to the waiting Starship for the descent to the lunar surface. NASA hopes to send the first woman and the next man to the Moon in the 2027-28 timeframe after an unpiloted Starship moon landing. Rapid reusability is a key element of the program given the number of super heavy Starships that will be required for a single moon landing. While Sunday's test flight appeared to go smoothly, multiple flights will be needed to perfect the system and demonstrate the reliability required to carry astronauts. How long that might take is an open question. Over the past few weeks, Musk has launched a social media broadside against the Federal Aviation Administration, complaining that the agency's bureaucracy takes too long to review and approve launch licenses and is in effect stifling innovation and slowing development of the new rocket system. The FAA did not grant a license to launch Sunday's test flight until the day before. But this time around, the license covered multiple test flights using roughly the same flight plan.
Astronomy Daily, the podcast. Astronomy, space and science.
And I don't know where you might have been on Thursday night. That's October 10 this year, but you may have seen or witnessed the wonderful colour displays in the sky. The auroras were very active. It's been a bit difficult to see them from where I am in Newcastle on the east coast of Australia, north of Sydney, but a lot of my friends further south saw some pretty spectacular things. Astronauts have probably got the best view of all, and we'll hear about that in a second. NASA astronauts Don Pettit and Matthew Dominic are in a very exclusive club indeed, getting a bird's eye view of the amazing auroral displays, which was supercharged by a recent solar storm from the International Space Station, and the sight took them completely by surprise. Pettit wrote, "Stunning was the word." He wrote a lengthy post on X on Friday that shared the post, a photograph of the celestial light show, and the sun goes burp, he says, and the atmosphere turns red. Spectacular, not only from Earth, but also from orbit as well. Words probably only an astronaut can really see the clear meaning behind, but the auroras were especially dramatic overnight on Thursday thanks to a strong geomagnetic storm which was triggered by the arrival of a huge cloud of solar plasma rocketed into space by a coronal mass ejection, a CME. Now, some of you may be wondering, what is a coronal mass ejection? Well, a coronal mass ejection is often compared to solar flares. They are bursts of electromagnetic radiation that travel at the speed of light, reaching Earth in just over 8 minutes. But CMEs travel at a more leisurely pace, relatively speaking, that their highest speeds of almost 1,900 miles per second or 3,000 kilometres per second, CMEs can reach Earth in about 15 to 18 hours, while slower CMEs travelling at around 155 miles per second or 250 kilometres per second can take several days to arrive. That's according to the Space Weather Prediction Centre of the National Oceanic and Atmospheric Administration, or NOAA. These relatively slower travel times are useful as they give us more time to prepare for such an arrival. CMEs can wreak havoc with power grids, telecommunication networks and orbiting satellites and expose astronauts to dangerous doses of radiation. Conversely, CMEs are a welcome visitor to skywatchers worldwide as they can trigger impressive aurora displays that are visible at latitudes beyond their normal polar range. Coronal mass injections form similarly to solar flares as a result of the twisting and realignment of the sun's magnetic field, known as magnetic reconnection, according to NOAA. When the magnetic field lines tangle, they produce a strong localized magnetic field which can break through the surface of the sun at active regions, subsequently generating CMEs. Effectively, the sun goes burp and we get a colourful sky. If you missed the amazing displays of colour in the sky, you'd be hard-pressed to miss them online. A good collection of images can be found over on space.com, where many images show the varying colours seen from a lot of different locations around the globe. In his Friday X post, astronaut Pettit said he and astronaut Dominic didn't expect to be so dazzled. This event caught both Dominic and I off guard. The aurora had just been so-so and we were out of energy at the end of a long day and reluctant to once again set up our cameras for yet another no-show. And we were just heading to some much-needed sleep when we made the mistake of peeking out the cupola windows, Pettit wrote, and what they saw jarred them into action. It looked like the space station had been shrunk to some miniature dimension and inserted into a neon sign. We were not flying above the aurora, we were flying in the aurora, and it was blood red, he added. Caught off guard, we hastily set up our cameras, 4 of them, all snapping shutters as fast as they could, creating a syncopated rhythm that accented nature's artistic display presented before us, he wrote. As the post notes, both Pettit and Dominic are practiced orbital photographers. Both routinely share stunning shots of the Northern Lights and other sights on Earth with us via social media. For example, Dominic recently gave us dramatic views of Hurricane Milton, churning towards its Florida landfall, which occurred on Wednesday evening, October 9. Those shots were taken through the window of the Crew Dragon capsule Endeavour. Dominic also shared an aurora shot through the Endeavour's window on X this week. I now sleep in Dragon Endeavour while we wait to undock, he wrote. We take most of our images from the cupola, but sleeping here has been amazing. This is the view out the window this evening, he wrote in the post. And listeners, I do encourage you to go to space.com and look at that photograph. In my opinion, it is one of the most amazing space photographs ever taken. Yes, it sure sounds like an adventure to me. I think astronaut Pettit is staying on board for a while. He went up there with the Russian Soyuz craft, but Dominic has already come home. He flew back on the Dragon Endeavour on Sunday.
And that's it for another episode.
Yes, that's all she wrote, and I want to thank you all for listening in. We bring you only a tiny slice of the stories that you can find every day in the Astronomy Daily newsletter.
I do hope you all find your way to the homepage and drop your email address in the slot to receive this fun publication each day.
Yeah, it's a terrific window on what's going on in space science and astronomy, and you can catch Anna with her presentations during the week, and we'll be back on Monday. So it's goodbye from me.
See you later, human.
See everybody.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.